So we talk about free fall motion next, and motion that occurs when an object near the Earth is departed, initial velocity up or down, and thereafter moves along a vertical line is called free fall motion. Okay. Then your book says, we assume the object moving along an S-axis whose origin is at the surface of the Earth and whose positive direction is up. We call the constant g, the acceleration due to gravity, is about 9.8 meters per second, or 32 feet per second, or square per second, squared, I should say. All right, so here's our formulas for position and velocity with the acceleration due to gravity, okay? Now, the g value you use depends on the problem. Are we talking about meters or are we talking about feet? And that determines which g value we use in each one of those. All right, so what we're going to do next is we're going to work the example that we have here. All right, let's see what they have here. They have an example and it says, assume a free fall model applies. A projectile is launched vertically upward from ground level with initial velocity of 16 feet per second. Oh, I like what they give me there. They give me initial velocity is what? 16 feet per second. I'm going to write that down. Then it says for part A, how long will it take the projectile to hit the ground? How long will it take the projectile to hit the ground? So my projectile is going to be launched upward, and it's going to come back down, right? Well, let's find our position function, S of t. What was S of t? S subscript to 0 plus V subscript to 0 times t minus what? What did they put? 1/2 or they put g next? They put minus what? 1/2 g times what? T squared, right? According to what we just had on the board a little while ago. All right, so S of t is equal to, what's my initial position? If it starts at ground level, if the rocket starts at ground level, what's the initial position? It'll be 0. Plus my initial velocity, they tell me, is 16t minus 1/2 times g times t squared. Now, what am I looking at? I'm looking at feet per second. So I'm going to use the acceleration due to gravity with feet in it, okay? Which one was that? 32 feet per second? Or per second squared. I don't know why I keep forgetting the squared. All right, S of t is equal to 16t minus, what does that give me? 16t squared? There's my position function. Now, what do they want to know? How long will it take for the projectile to hit the ground? So how long will it take for my projectile to go up and back down and hit the ground? Well, what is my position equal to when it hits the ground? It's equal to 0. So let's find out where this position function is equal to 0. So 16t minus 16t squared, I'm going to find where that's equal to 0. Well, let's solve. I can factor a 16t out of each one of these terms, and I'm left with 1 minus t to the first is equal to 0. Take each one of these factors and set them equal to 0. 16t is equal to 0, and 1 minus t is equal to 0. So if I solve this one, I get t is equal to 0, which we already knew. We already knew the projectile was at the ground whenever it was launched at 0 seconds. How about this one now? T is equal to what? 1? So how long will it take for the projectile to hit the ground? 1 what? 1 second. Let's look at part B here. Part B reads, how long will the projectile be moving upward? All right, let's think about the projectile. Fired up, goes up, and for a brief moment, it's like it pauses, then it comes back down, right? So, at that brief moment where it pauses, what is my velocity if it pauses? Wouldn't it be 0? So, how do I find when it hits its highest point, or where it stops moving, I should say, whenever my velocity function's equal to 0? So let's find our velocity function and set it equal to 0. What did we talk about for the free fall motion? What's the velocity function? V subscript to 0 minus what? G times t? So my velocity function will be, what's V subscript to 0? 16 minus G, we said was 32 times t, right? All right, so there's my velocity function. What y'all tell me to do with the velocity function? Set it equal to what? 0, right? So take this 16 minus 32t and find out where it's equal to 0. Well, let's see. Negative 32t is equal to negative 16. Divide both sides by negative 32, and what do I get? 1/2. So now, what does that mean? My velocity be 0 at 1/2 a second, or it stops moving what? Upward at 1/2 of a second.